Hey, it's Joel. We're at Formnext 2025 at the Atlix booth, and I'm here with my buddy Eric. What's going on?
Hey, how you doing?
I'm doing all right.
Great.
So Atlix wasn't always Atlix, right? We were TruPrint before, correct?
Correct, yeah. TruPrint has a long legacy of building machines that are stalwart industrial grade production machines.
That's why you get something like this, which is a 10th generation machine, correct?
You're right. This is the latest generation of our industrial production machine.
So you get all of that history, and now you've got the TruPrint 5000. Take me through the TruPrint 5000. What's the first thing that comes to mind as far as a feature-rich machine?
This machine has four 1 kilowatt lasers, and if we start with 4.
Wow.
But more lasers is not necessarily better.
Okay.
This machine is a 500 millimeter by 500 millimeter by 400 millimeter depth machine. We judge that as the right build volume for the requirements of the industry today. So we judged that 4 lasers was the right, 1K lasers was the right number. They're TruPrint lasers. The principal key differentiator that I want to bring to the audience today is our automated multi-laser alignment. We're aligning and calibrating the lasers every layer, as opposed to others who put a calibration plate in, calibrate the lasers, take the calibration plate out, run the machine, and hope for the best.
If you're doing something per layer, are you sacrificing print time to do the per layer?
600 milliseconds.
That's it.
That quick?
Yeah, not at all.
And of course, we're spreading material in 2 directions, so the idle time of the machine is reduced. All right, so automated multi-laser alignment.
Okay.
That's key. I guess the next most important thing in a laser powder bed fusion system is the gas flow. Because we're running inert gas across the build surface to take away the smoke load that comes from the melting process, right?
Right, yeah, the inert gas, so it doesn't fill the chamber, you flow it over the top?
Lasers have to get to the surface,
Yeah, of course.
And they can't go through the smoke and through the spatter, so you have to clear that away.
Okay.
We use a laminar side flow technique that, as opposed to a top-down technique, and we're able to show that the gas flow dynamics are everywhere the same on the build plate.
Oh.
That's key, because if you're building a part in the outer corners of the build plate as opposed to the center, you need to have the same laser intensity and the same gas flow dynamics, because those are the 2 physical properties that define the material characteristics on the part. But that's not all. Automation is important too, right?
Absolutely.
In the guts of this machine are 2 build cylinders. So there's 1 cylinder waiting and 1 cylinder that's up against the build chamber.
Okay.
So after this build is done, the machine automatically caps the build to keep it inert. It drives it down and it moves over into the right-hand position here. And then an idle empty container is waiting, and it's automatically brought in and kissed up to the bottom of the build chamber, all while keeping the inert environment so you don't have to dump the gas load.
Oh, okay, so if this finishes at 4 o'clock in the morning and no one's on shift, it just starts over again, and you've maintained an inert load in both, like the gas is not sacrificed.
Correct.
That's
Correct.
cool.
Nor is exposure of the parts, right?
Right.
Right.
And that's very important too for a
So
consistent part quality.
The machine, exactly. So the machine will restart by itself in 15 minutes.
Well then, with the one that finished and you've maintained that inert load, then a machine operator can come along, move that out, and you've maintained that inert load.
Absolutely.
It's closed, right?
Yeah, so the empty build tanks come in on that side of the machine, and the finished builds come in on this side of the machine, capped, and then they go into the unloading station, also inerted, and they're cleaned out. So the only time you expose the part to the atmosphere is after it's been completely cleaned and the powder's been removed and in a closed loop inert environment brought back to the powder handling station, and then you remove the part.
Wow. Well then, so this is one of the parts. I know you've got other parts in the stand that are really big.
Yep.
What are some of your favorite examples of what this machine's been able to do?
Well, look, we have a big part over there that's a shower head for semiconductor processing equipment. So it's a very complex fluidic network where plating materials are pushed through to manufacture semiconductor parts. Yeah.
Well, and something like that with the fluidics in it is not something that they could manufacture any other way,
no,
correct?
It's the only way. No, that's the beauty of additive. Additive is enabling geometries that were never before realizable.
What else you got over there?
medical devices, dental, defense and aerospace.
Sure, defense and aerospace, right?
Yeah.
But wait a minute, dental. Is there a lot of metal additive in dental?
Lots. It's crown.
Is it really?
Crown and bridge.
Wow,
Yeah.
I didn't know those were additive made. I thought that was a doctor.
Okay, that's the patient-specific medical device area, because every one of them is different.
Yeah.
And that's why additive manufacturing or 3D printing is perfect for that. Most 3D printed medical devices, implants, are made with additive manufacturing in order to introduce the trabecular structures on the surfaces of the parts, which help promote osteointegration, basically for bone integration.
Right.
And it's additive's ability to make those very fine lattice structures that enables those parts to be successful once implanted.
I have had some metal additive bone screws, and I was able to do a demonstration how bone screws could get themselves into the trabecular structure of the bones easier. I did a demonstration, and I printed in a polymer the trabecular structures, but you're saying that the implant parts themselves can be printed with that structure for osteointegration.
Yeah, titanium is a wonder material, because it just so happens to be very biocompatible and promote the best osteointegration.
You could
Bone
print really
likes
well.
titanium.
Yeah.
But this part is a very interesting part as well. I don't know if you're aware of what the
This is a suppressor.
A suppressor, yeah.
And you would 3D print this because being able to manufacture that part would either by hand take a long time, or you wouldn't make it this way at all.
Well, yeah, so suppressors are typically made with an outside tube and a variety of other components internally, and it's assembled.
Yeah.
And those suppressors work quite well, right? But as it turns out, the best way to make the most effective suppressors is using additive manufacturing.
That's so cool.
Because we can make this very complex internal structure in one go. So the suppressor.
Well, that's it, in one go.
In one go. And you can see on the build plate there with 100 of these suppressors on one layer, and of course you can add another layer
Well, of course,
on top of that. Yeah.
But I mean, really, that lends itself to the power of additive, because if you take less time to make the part,
right,
then the cost is reduced, the time to produce is reduced, and it's a solution for multiple problems. It just has to enter those industries.
Look, that's the challenge for us additive manufacturing equipment suppliers, right? In order to make a machine better and faster, the machine doesn't get cheaper, the machine gets more expensive.
Sure.
Right, but that's okay, because in order to make parts less expensive, you just have to make machines faster, and that's what we're doing.
Yeah, well, but faster, maintaining a same quality bar or higher.
You have to make them faster and better.
Yeah. All right.
And that's what you get out of this machine.
There you go, on the TruPrint 5000.
Yeah.
Eric, this has been fun, man.
Well, I've really enjoyed your conversation.
This has been good. Hey, thanks for watching. If you made this fire awesome, don't forget to hug each other more, fight for a cause you believe in, print all the metal things, and as always, high five. You want one? Ooh.